Bismillahirrahmanirrahim. We continue our discussion on operating system and would start from where we have left the discussion in the class. In the class we were discussing what is an operating system, and we have defined different definitions, or we have defined operating system on the basis of its different functions. We had said in class that there is no specific or accurate or exact definition for operating system can be obtained, since operating system performs a lot of functions and every function can be termed as its definition. We also discussed some of the types of operating system, and we will continue our discussion on different types of operating system in today's discussion as well. Let's see the agenda, what we have already discussed and what points we are going to discuss today. In class we had defined operating system. Different definitions have been elaborated on the basis of the functions operating system perform, and then we switch to different types of operating system that will ultimately lead you to the history of operating system. The first system that came into being were mainframe systems. We had a detailed discussion on it in the class. In today's discussion we will be talking on the desktop systems. What are the desktop systems? Let's have a detailed discussion on it. So, our today's first point of discussion is the desktop system, which is also known as the multi-programmed operating systems. These are the common systems used by us today. Desktop system is actually another name given to multi-programmed systems. But these systems are dedicated to single user. So we can also call them as personal computers, as they are dedicated to a single user. Different input and output devices are attached to desktop systems, such as keyboards, different types of mice, display screens, printers, etc. You can attach any sort of input-output devices to your personal computer. These systems have all the characteristics as we had discussed earlier for the multi-programmed system, and they provide quite user-friendly environment and generate quick responses to user commands. So they are very easy to use and becomes quite responsive. You can get quick responses from your personal computers. Desktop systems developed so far and will be, if developed in future, are quite adaptive, and they can easily adopt the latest technologies, and since they are under use of a single user, so high level of protection to this type of operating systems are generally not required, though security should be provided to some extent, and it is done to some level which is quite enough for the protection of a single user data. So these are some of the common desktop operating systems, such as you can install Windows operating system in your personal computers. You can have Mac systems, you can install Linux, Unix, or these are some of the common operating systems running on your desktop computers. The next type of operating system that we are going to discuss, as it is mentioned in the agenda, are the multiprocessor systems. What are the multiprocessor systems? Let's proceed to its discussion. Here again, it is important to mention that these systems are extensions to multi-programmed systems. So multiprocessor system is an extension to multi-programmed system. Multiprocessor, as the name indicates, having more than one processors. That means more than one CPUs that are sharing one RAM. So multiprocessor systems, also known as parallel systems, they are actually having more than one CPUs in close communication as they share one RAM. The communication is generally done through the common RAM. The best example of this type of system you might have observed in shape of dual core, quad core systems, where dual core means having two processing units sharing one RAM, and quad core means four processing units sharing one RAM. These systems are also known as parallel systems, or you can also know them as tightly coupled systems. Why they are known as tightly coupled? Because all the processors sharing one RAM and the clock are tight. So the communication among these processors generally take place through this common RAM, and you are not able to disintegrate any of the processing unit out of the single motherboard. So all the processing units are intact on a single board. That's why known as tightly coupled. You cannot disintegrate the processing units. Jobs are generally stored in this common RAM, and results are brought back after processing to this common RAM. So if there are two processors, they get data from the same RAM. So at a time, two jobs will be assigned to two processors. Once they complete the execution of their jobs, the results will be returned to the same RAM. Now, why it is called tightly coupled? Because, as I just said, no processor can be segregated or disintegrated from other processors, as all the processing units are attached to single plate, and if the plate goes down, no processor would work properly. Such type of systems offer more benefits over the common multi-programmed system. So these are some of the benefits that we normally obtain from multiprocessor systems in contrast to a common single multi-programmed system. Single multi-programmed system are single CPUs having single RAM, while multiprocessor systems are the extensions of multi-programmed system having more than one CPUs but one RAM. So what are the benefits? It provides increased throughput. That means you can have more work done in less time as you have more than one CPUs. So more than one activities can be performed in less time as compared to a single multi-program system where you can get single activity be done in 1 unit time. So your multiprocessor system can execute more tasks in less time as compared to a single multiprogram system. So if it is a dual core multiprocessor system, that means 2 jobs will be executed at a time, while normal desktop system only executes a single task at a time. Another benefit or advantage is that they are quite economical, as they are available in shape of desktop computers which are affordable and provides higher reliability, which means even if single processor is not working, still the other processors on the plate will be working. So our tasks will be getting executed even if single processor is down. While on the other hand, single user or desktop system or a normal multi-programmed operating system having single processor, if that processor goes down, user task will not be processed. Hence, multiprocessor systems are quite reliable and are fault tolerant, which shows fault in one CPU will not affect other processor, while this is not the case with normal multi-programmed system, as their single processor is intact on single plate, so one processor is responsible for all the tasks, and if the fault in that processor arrives, your whole system gets down. So these systems are quite economical. That means you can have dual core, quad core system quite affordable in affordable ranges. So multiprocessor system is mainly an extension to multi-program system. They both have same functionality, but the difference is multiprocessor has more than one CPUs on a single board having a common RAM. They are also known as parallel systems as more than one CPUs are working parallelly, and they can also be known as tightly coupled systems, as none of the CPU can be disintegrated from the plate. All the processor needs to be intact on the plate, though if one processor is not functioning, others are still performing their task. Multiprocessor systems has 2 types: symmetric multiprocessing systems and asymmetric multiprocessing systems. The symmetry means similarity. So the symmetry in symmetric multiprocessing system is that a single copy of operating system is being executed by all the processors. So single copy of operating system is in charge of all the processors, and multiple tasks are executed at a single time without any effect on the system performance. So single operating system is running on all the processors, single copy of operating system is running, and every processor is performing different activities or executing different user jobs without having any effect on their performance. That means every processor has the capability of self-scheduling, that is, selecting tasks from memory, while on the other hand, the asymmetric multiprocessing, not all the processors are treated equally. Asymmetric multiprocessing means there is no similarity. That doesn't mean they may not have the same identical copy of operating system. Actually, the working mechanism is quite different in both the cases. In symmetric multiprocessing, a processor can select any job from the RAM and start working on it, while in asymmetric multiprocessing, they can be having identical copies of operating system on all the processors, but their working mechanism is different as compared to symmetric. Here, one processor would be in charge of all the processors. So there is a sort of client server or master slave sort of relationship between one processor and other processors. So one processor acts as master while rest of them behave as its slaves. So slave processors have no capability to schedule their tasks for themselves. They execute the tasks that have been delegated to them by the master processor. So every processor has no choice of selecting their processes. The task that has been delegated to them by the master processor have to be executed by them. Symmetric multiprocessing is very common and can be applicable in desktop computers that can support any modern operating system. But asymmetric multiprocessing is mostly used in large systems such as the system in heavy industries or some manufacturing units. So they are quite complicated systems. Asymmetric multiprocessing are quite complicated, while symmetric multiprocessing is quite simple, which we can easily found in our desktop systems in shape of dual core systems or quad core systems. While asymmetric multiprocessing systems are not quite easily available in desktop computers, they are generally found in large manufacturing or industrial units. This is the architecture for multiprocessing system. As you can see, multiple processors are connected by single RAMs. You can see here different processors are connected to single RAM, and this connection is through internal buses. These are the internal buses which are connecting these processors with not only one another but also with the RAM. So the communication between the CPUs and memory is done through these internal buses as shown in the black lines. The next type of operating system that we are going to discuss is the distributed system. This is again a type of desktop system or a type of multi-programmed system. It is also an extension to multi-programmed system. So next type of operating system is distributed system. Distributed system has the capability of multi-programming and multiprocessing besides adding its own different flavor. The main difference between multiprocessor system and distributed system is that multiprocessor system have multiple processors sharing one RAM, while in distributed system a complete independent computer is taken into consideration. So distributed system is mainly the collection of complete physical computers that have their own memory, processors, and any type of operating system may be installed on them. So here the main idea is to distribute the computing resources, or the computational power is distributed among several different physical computers. They are physical processors, independent computers having their own memory, having their own input-output devices. So all these independent computers communicate with each other through different communication lines, such as internet. So they are also known as loosely coupled systems. While if you remember, multiprocessor systems were known as tightly coupled systems, and this distributed system is known as loosely coupled system because every system is treated, or every computer is an independent computer having its own RAM, its own processor, its own devices. So any computer can be easily disintegrated from the pool of computers. Generally, distributed system helps in solving problems by collaborating different independent computers scattered worldwide. These systems are also known as loosely coupled, as I just said, since every processor has its own memory. In short, it is a complete computer. Why it is known as loosely coupled? Because if one processor goes down, so it can easily be taken out of the network without affecting the performance of other computers. So here computers can easily be added and removed as you connect to internet, both with your laptops, palm tops, and your mobile phones, and can anytime be removed from the internet. So distributed computers have the power of distribution. That means you need to connect different computing devices together using some communication line, and generally internet or some high-speed buses or telephone lines are used to connect different computers. So here computers can easily be added and removed. Different benefits are provided by the distributed systems, such as the major benefit that it provides is the resource sharing. For example, when you are using third-party resources for your task on internet, so actually you are sharing his resources. The way you might have used Google Documents and all your emails are stored on Google Drive. If you have Google account, so both software and hardware resources of Google are being shared among billions of people across the globe at the same time. Computation of your work goes speed up. This is the second benefit, because different processors are taking part in solving your problem. So once it is started, once you have started to solve your problem, the load is then shared. The load of your problem is then shared on multiple computers. For example, when you Google something on, when you search something on Google, you get a lot of responses. A lot of websites are generated as a response to your query. That means millions of computers are working to solve your problem, to generate responses to your queries. So actually the load of your problem is being shared among different computers. Next benefit that distributed computer is providing is the reliability factor. Why it is reliable? If one processor is not responding, that means if one of the computer is not responding to your query, still other computers are there to help you out. For example, if you have Googled something on the search engine, Google search engine, and one of the link is not working, still other links are there to help you out. And the best is different means of communications are provided, which can be either wired or unwired. So you can have a lot of options to communicate with different other computers Those options can be either wired means of communication or can be having unwired, such as Wi-Fi for your communication. So this is the benefit of distributed system. Distributed system is mainly a type of multiprocessing or multi-programmed system, but it actually distributes the computations among different physical computers which are scattered over the internet. So internet is the best example of your distributed environment, where you connect your computer with another computer using some communication lines, such as telephone lines that can be wired lines or unwired lines such as Wi-Fi, and share your problem and get the solutions from different computers. Distributed system requires a networking infrastructure. So, as we just said, here the computers are scattered, or the computational power is scattered over the internet. So you must have some networking infrastructure in place. So any network will work. Either local area network can form a distributed system. You can connect to your computer using some Bluetooth devices. A man communication is also acceptable, and the most common that we use generally are the wide area networks. Different applications are developed using distributed systems that can be either client-server or peer-to-peer systems. Client-server is similar to master-slave sort of architecture, while peer-to-peer, in which you generally treat every computer as an independent computer, getting responses, getting problems from every computer is treated similarly. This is the common architecture for distributed system, and this is the model for a client-server environment. As you can see, I have shown the client-server architecture where different clients which are actually complete and independent computers. These clients are the complete computers, such as your phone, mobile phone, your smartphone, your computer, your laptop. These are the clients. They are complete independent computers. They are connected to a single server, such as the Google server. So millions of computers ping this server at the same time, and it generates responses accordingly to their needs. There has to be some networking architecture between the clients and the server. That can be some wide communication mechanism or can be some wireless communication network. The next point that we are going to discuss is the types of distributed system. So first we are going to discuss the cluster systems. Distributed system has different types, and one among them is the cluster systems. Cluster system is similar to parallel systems as it possesses multiple processors. Clusters are generally made up when two or more computers are grouped as clusters. Two or more computers are when grouped together to form cluster, and they share some storage. The communication among these computers is generally done through local area network. So that means they must be formed within a building inside some local area. So clusters are formed in close vicinity. Mainly clusters are made up to solve single problems, as they require to have homogeneity among cluster computers, both in terms of software and hardware. The main benefit it provides is reliability, high reliability and availability. As all computers are working for one single problem, so many among the remaining available computers at any time and keep on working even if few computers are down. So they are highly reliable. That means if there are 4 computers joined together to form a cluster, so if 3 among them are working, still our problem is getting solved. If 2 are working, still the work is done. So they are highly available and reliable. Clusters has 2 types: asymmetric cluster and symmetric clustering. Since all the computers within a cluster are considered as single system, so in symmetric clustering, all the computers within the cluster run the application to solve the problem, besides monitoring each other. So in this way, multiple solutions to a problem can be obtained. While in case of asymmetric clustering, one processor serves as server that divides the problem into fragments, and every computer is given one fragment of the problem to work on it instead of sharing the whole problem. So asymmetric is sort of client-server atmosphere where the master divides the problem and sends a portion of a problem to a single computer. While in symmetric cluster, the complete problem is shared among all the computers in order to obtain multiple solutions. Next type of distributed system that we are going to discuss next is the real-time system. This is another type of distributed system. Real-time systems have well-defined time constraints, and they're mostly used as control devices, most commonly in the dedicated applications to ensure the results well in time. So they generally are used as control devices in dedicated applications. Such systems are commonly used in medical image sensing, such as the ultrasound devices, etc., in scientific experiments, industrial systems, and also in display systems, such as if you do video calls from your phones. So you are actually using a real-time system. Real-time system is of 2 types. They can be either hard real-time or they can be either soft real-time. So what is the difference between the two? Let's see that. Hard real-time system is the one which are bound to strictly respond in time, and no relaxation is provided in time, such as the systems used in medical image sensing, for example, ultrasound machines. They never store the results, so there is no secondary storage. Your ultrasound results are never stored on computers. Data can't be stored for long and is only available to be read without any modifications made. So such systems are not provided on all types of computers, as mostly general purpose computers use general purpose operating system, but they do not have hard real-time features. The other type of real-time system is the soft real-time. That means it can accept little flexibility in time, but not much. For example, if you are having video calls and the video is getting saggy or stuck time to time, but the voice or sound is clearly audible. So such system is known as the soft real-time system, because it may not generally harmful to the user, but stacking for longer may hamper the communication. Such systems are commonly used in industries, multimedia, virtual reality such as the live streams or live video conferencing, and all of the modes modern operating system can use soft real-time systems. The modern operating system have the soft real-time features, but they do not have the hard real-time features. So hard real-time systems are only provided at limited locations where there is strictly bound on time, while soft real-time features are provided in almost every latest operating systems, such as we generally have in our systems for the live video conferencing. Another type of distributed system that we are going to discuss next is the handheld system. Handheld system, as the name shows, your mobile phones or your smartphones. So another type for distributed system is known as the handheld system. Handheld means the devices that you can easily carry them in your hands, such as your cellular phones. All types of mobile phones, smartphones, your tablets are known as the handheld systems. They also carry some type of operating system in them. They can also be known as your personal digital assistants, as you can solve all type of your problems on your handheld devices as compared to the desktop computers. They are small in sizes, you can easily carry them as compared to the heavy desktop computers. Apart from the size, handheld devices carry some issues, and these are some of the issues. The major issue is the memory. As compared to the desktop computers, your handheld or cellular phones have limited memory. As a result, slow processors and the display screens are also small. Since they have limited memory, that means there must be slow processing in them. The processors are slow, and also the display screens are small as compared to your desktop computer screens. But they can support all type of latest operating system. They are quite efficient, quite helpful in carrying and solving user problems. But these are some of the common issues as compared to desktop computers. They become less handy due to limited RAM and slow processing powers. So this is the diagram showing yearly which type of operating system arrived and how it evolved, covering all the different types we have discussed. You can see mainframe computers arrived between early to 1915s, and there were no software initially. And then software started to develop, and compilers arrived during 1950s and 60s. And batch operating system arrived also during that time, 50s and 60s, having resident monitors. Mini computers arrived during 1950 and 60, having same batch systems and time-share system features. Microcomputers arrived during 1960 and 70. As you can see, first commercially available multi-programming system for desktop computers arrived during 1960 and 70 with the name Multiprocess, which grew with the time and became Unix. And it then added different other characteristics as already discussed for different desktop systems such as distribution, multiprocessing, real-time, etc. So this is the complete graph showing evolution of operating system yearly. Different computing environments are there. It was a time when people used to use their personal computers to solve their problems without having distribution or networking features. So traditional computers, when we used to use computers without distribution or without networking, then networking infrastructure developed and people started to solve their problems using internet. So web-based computing then arrived. We now solve our problem using different websites, and special operating systems have been designed for them, such as Windows Millennium. While currently we are living in embedded computing environment. This is our current era, where every electronic appliance in our home having computational capability, such as your ACs, microwave ovens, your vehicles, etc. That is all for now. Here you can find the useful link to download the book for this course. Here we come to the end of this chapter. This was the introductory chapter to operating system, in which we defined operating system on the basis of its different functions. So a lot of definitions we have made. Then we defined different goals why operating systems were developed, and then we discussed different historical evolution of operating system. That includes different types of operating system, what it was earlier and what it is now, how we use operating system, what are its features. We are currently in the distributed system era. Our computers have operating system that have the distribution capability. So that is all for this chapter. We will continue our discussion on the working of or the functions of operating system in the next chapter. If you have any queries, you can email me. My email address is written here. I thank you all.